One of the Elm primitives I use quite often is maybe. Maybe is an elegant way to describe whether a value does or doesn't exist. If a value does exist, then you get a just of that value. If it doesn't exist, then you get nothing. But the real question on everyone's lips is, how do we implement a maybe in Go? Well, today we're going to answer that question and fully implement the Elm Maybe module in Go. We're going to be writing tests, we're going to be moving quickly, so grab yourself a comfy blanket, dim the lights, and let's check it out. So if we head on over to Elm Packages, in Elm Core and the Maybe module, you can see that this is where our maybe is defined, and it's a sum type of maybe of A. And there are two variants here. We have a just of A and a nothing. And this is the type definition that we need to create in Go. So let's start a project and get started. I'm going to create a directory called Go Maybe. I'll cd into that directory, cd. And now I'll just initiate a Go project with go mod init, Go Maybe. Okay, let's open it up. And the first thing I'm going to do is add a package directory. In that package, I'm going to add a maybe directory and then a maybe.go file. Let's go ahead and just do package maybe. Nice. Okay, so we need to create a maybe type. Now we don't get sum types in Go, but we can get something that sort of behaves like a sum type. So let's go ahead and do type maybe. And this is going to take a generic A of any. If we look back at the Elm packages, we can see that here it's a maybe of A, and A here means any. So it's kind of the same thing. Back in the code, this will be an interface. And in the body, we're going to add a private method, maybe, and this is going to return an underscore maybe type. The reason we are doing this is so that the maybe can only be created from this module and not externally. Let's define the type underscore maybe, and this is just going to be an empty struct. For the method, we're going to do a method for the underscore maybe. It's going to be called maybe, and it's going to return the underscore maybe. And in the body, we just return the M here. Okay, now it's time to define our variant. So let's define a just. Now this just is going to take a generic A of any, and it's going to be a struct. Inside, this is going to represent a value. So it'll be the value of that A. We're going to define our nothing, and nothing doesn't take any generic because it's a nothing value. And inside, we're just going to actually implement the underscore maybe. And we also have to do that for our just as well. And that's it. We have our maybe type defined with just and nothing variants. So how do we use these variants? It's probably a good idea to see how we do this in Elm. So what I'm going to do is create a file called maybe.elm. I'm going to do a function called do something, and it's going to take a maybe string and return just a string. Do something takes our M. Okay, so the way we actually access the just value of the maybe is through a switch statement. Well, it's actually a case statement. So we do case M of just V, and then we can just return that V because that holds the string. And in a nothing case, we can just make up a string and just do foobar. So for this, we want a similar API in our Go code to work with maybes. Unfortunately, we don't get pattern matching in Go like Elm, but we can make something that's pretty close, and it's going to probably be the most important useful function in the package. So let's create that right now. Okay, back in our maybe package, let's create a public function called MaybeWith. We'll give it some generics, V of any, which will satisfy our maybe, but also an R, and this represents a return value, and it's also any. So we'll take an M, which is a maybe V, a J, which is a function that takes a just V and returns an R. So this is handling our just case, and also an N, which is a function that handles our nothing case, and that also returns the return value. In the body, we're going to switch on M, and let's just make sure we put an R here. We're going to switch on M, which we bind to the maybe type. And by doing this, we can actually pattern match on the variant, so the just and the nothing. So here we're just pattern matching on the just value, and we're going to return the J function called with the M. And same thing for the nothing. We're going to call the N function called with the M. So Go switch statements don't enforce exhaustive matches. So we do need to add a panic down here. And I'm just going to put unreachable. And the only way this is going to actually panic is if we add variance to our maybe, which we're not going to do. So we can be pretty sure that it's going to be fine. Now, all this might look a little bit weird, but trust me, you're going to see the real power of this function. It's going to save a whole bunch of boilerplate code for us. Okay, so let's start with the very first maybe function. In the maybe docs, that's the WithDefault. WithDefault takes an A of type any and a maybe A and returns an A. So this means if the maybe I pass is nothing, then what we expect back is the default value we pass. Otherwise, if it's a just, then we return the value of that just. In our code, let's create a public function called WithDefault. We're going to give it a generic of A, any, and the first arg is going to be an A of type A. The second argument is going to be an M, which is a maybe of A, and what we return is A. So this follows our function definition in the Elm docs exactly. In the body, we're going to utilize our MaybeWith function. So we'll return a MaybeWith. The first arg is the M, which is the maybe, and now we provide functions for each variant. The first one is the just, so it's a function that takes a J, which is a just A, and returns that A. So in the body, what we return is the J dot value in this case. The next is the N, which is the nothing branch. And what we want to do here is because we have a nothing, we want to return the default value that was passed in. And that's pretty much it. We implemented WithDefault. Let's write a test to better understand what's happening here. Okay, I'll create a file called maybetest.go. And this is going to be a package maybe. I'm going to add a few imports here. The first one's going to be testing. And the next one is going to be github.com/stretcher/testify/assert, which is going to make our asserts way easier to work with. Now we're going to need to make sure that Go can see these. So let's go to the console and do a go mod tidy, and Go's going to install those for us. Awesome, done. Now we can actually start writing some tests. Okay, I'm just going to restart the LSP here because it hasn't picked up the new package. And that should fix everything. Yep, awesome. So the first test I'm going to write is going to be called test with default. At the top, I'll add an asserts variable, and I'm going to bind it to assert.new with T. Now the first test is going to be nice and simple. With default with nothing. Okay, I'm going to add a var of M for maybe, and this is going to be a maybe int. Then we can set that M to nothing because we're testing the nothing branch. Okay, let's asserts.equal, we're going to say 22. And then we're going to call the WithDefault function with our default value of 22 and the M. Let's run the test and see how we go. Go test package maybe, and it's thinking for a bit, and test passes. Nice. Okay, let's just now copy the test and test the just branch. So this is going to be with default with just. And instead of nothing, let's bind it to a just int of value 2. And this time, because it's a just, we're actually expecting it will return the value in the just, which is 2. Let's run the test, see how we go. Passes, awesome. Making good progress. Okay, let's see what's next in the docs. Looks like map is up. From the signature, we can see that map takes a function that takes an A and turns it into a B, as well as a maybe of A. The return value is going to be a maybe of B. So this is a classic map function. Let's do it. Okay, let's create a function called map and give it the generics A, which is any, and B, which is also any. The first argument is a function which takes an A and returns a B. And the next argument we're going to call M, and it's a maybe of A. Now the return value for this function will be maybe B. Once again, we're going to use our handy dandy MaybeWith function. We'll pass the M and supply a function for the just branch, and we'll annotate what the return is here. In the body, we just return a just of B, and the value is actually going to be the function passed in called with the J dot value. Then for our nothing branch, we just return nothing. And that's it. We've actually created a map, and don't tell anybody, but this is an implementation for a monad. So there you go. Okay, let's create a test for this bad boy. Here we're going to call this test map. And the first test is just going to be map with nothing. So we're going to map a nothing. Let's make this m value a maybe int, and let's bind it to a nothing variant. Okay, let's assert dot equal. It's going to be nothing. And let's call our map function. And we have to pass it a function. So it's going to be just an anonymous function that takes an a, which is an int, and it's going to return an int. And in our body, we're just going to return 2. And we also pass the m, the maybe. Let's run the test and actually see how we did. Lovely, passing test, awesome. Okay, let's now create the just version. I'll just copy this. Now we want to bind this to a just int value 2. And for the function that we pass, let's do something a little more interesting. Instead of returning 2, let's take the argument and add 2 to it. So what we're expecting, because of the just value we have, is actually the function return. So what we expect is a just int value 4. And let's run the test. Awesome. Okay, let's check out map 2. So examining map 2, we can see that it takes a function that takes an a and a b and returns a value. There's nothing special about the name value here. They could have just said C here instead. It also takes 2 maybes, a maybe of A and a maybe of B, and the return value is a maybe of value. So map 2 will work exactly the same as map. It's just that we have a few more arguments to deal with. Let's do it. Okay, so let's call this map 2. And we're going to give it the generics A, any, B, any, and a value of any. Okay, so the first argument is a function which takes an arg of A and B and returns a value. We also take an M1, let's call it M1, and that'll be our first maybe, maybe A, and an M2, and this can be maybe B. And the return value for this function map2 is going to be a maybe value. Much like before, let's return a MaybeWith and give it the M1. So let's pass a function for the just of A, and it's going to return a maybe of value. I'm just going to fill in this block in a second. Let's just handle the nothing case first. So in the case of nothing, we're still returning a maybe value, but we return nothing. Okay, so for the just of A branch, we need to actually resolve the second maybe. So what we return here is a MaybeWith, and this time we pass it the M2 maybe. So we pass a function for the just of B with a return value of maybe value. And inside of this block, we return the just value, and the value is actually going to be the function with the J1 value and the J2 value. For the nothing branch, just like before, we're still returning a maybe value, but we return nothing. Okay, the LSP is happy. Let's actually write a test. Okay, so in the test here, I'm just going to copy the map test and just change it to map2 of nothing. Now up here, we're just going to call this one M1 and an M2. Let's bind nothing to one and adjust 22 to the other. Okay, so what we want to do is take in that extra argument. And here we're going to just return A plus B and make sure that we add both our M1 and M2s. And let's make sure we're calling map2. And let's run the test and see how we did. Test passes, nice. Okay, let's do the just test. And here, let's make both of these a just of 22. So for our M1 and our M2, we're going to make this a just of 22. Pass our M1, pass our M2, and let's actually name this correctly. That's going to be an int. Same deal, we're going to do A plus B, And that's meant to be a B, sorry. Okay, so what we're actually returning here is the return value of the function that we pass in, because we're working with two just maybes. It's just going to add both values. So 22 plus 22 is 44. Let's run the test. Beautiful. Yeah, we're doing it. Okay, so I'm just going to go ahead and add the other maps. And they're going to be working exactly the same. I've just pasted those in here. They work exactly the same as map 2 and map. It's just that there's a whole lot more nesting. And have a look at the code, see how they work, but they work exactly the same. Okay, so looking at the docs, our last function is actually called AndThen. And I use this function a lot, so this is going to be a good one to implement. So it's like a way to chain maybes. Let's get it done. Okay, this is going to be really easy to reproduce. So down here, let's create a function AndThen with the generics of A of any and B of any. It takes a F, which is a function that takes an A and returns a maybe of B. We also take an M, which is the maybe of A, and the return value for this function is going to be maybe of B. Okay, let's return our trusty MaybeWith function and pass it the M. Let's add a function for the just of A. And here we return a maybe of B. In the body, all we have to do is call the passed in function with the value of the just of A. For the nothing branch, same deal as before, we return nothing. And that's it, time for testing. Is that a test? And we're going to call it test AndThen. And I'm just going to do the necessary boilerplate code here with our asserts. Okay, so for the first test, let's do an AndThen of nothing. And here we'll add a var of M, which will be a maybe int. Let's set it to nothing. And here we're going to asserts dot equal nothing. And then we can call the AndThen with an anonymous function that takes an int and returns a maybe of int. Why not? In the body, let's just return just of int with a value of 22. Okay, let's run the test, see how we go, and test pass, nice. Okay, for the just test, let's copy this one. And this one's gonna be just. And this time, let's make the maybe a maybe of string, just to do something a little different. And here we can call string and let's call it hello. So the just value will be hello. In the asserts, let's actually use the argument in the function we pass. And for the return value, let's add it to a string of world. So here it's just going to be just string, and let's add world to our A. And so for the assertion, we're going to be adding hello to world. There's no spaces, so it's going to be a just string, and the value is going to be hello world, and it's capital W. Yep. All right, let's run the test, see how we go. And boom, done. And then it's finished. And just like that, we've implemented the entire Elm Maybe module in Go. And it actually wasn't that bad. I've got a sneaky project where I'm porting more Elm things over to Go, so make sure you're subscribed so you don't miss out on those videos. I really hope you got something from this video. Perhaps you're more familiar with Maybe, or maybe you just learned some new Go things. Thanks.